Hey guys, Sunday night videos for Sunday night. We're starting chapter 15, our last chapter to fresh one before Christmas. We get a couple, and hopefully it's not too bad. The first part of the chapter is talking about relations, and as you get this formal definition, a relation is any set of points which connects two variables. We've got this simple little table of values, which is what this is called. And the connection is cost based on weight for shipping a parcel. So the cost is connected to weight. That's what the relation is. So, or they put it here, the cost of posting the parcel, a fixed distance is determined by the weight of the parcel, as shown in the table. So we've got the table. They then convert that to a graph, and this is called a step graph. So the representation of, if it's, let's see, $5 is for 1 kilogram to less than 2 kilograms, and then 2 kilograms to less than 5 kilograms. And they do that step, and that's how this is graphed. This is called a step graph again. What we're going to run into is different ways to represent data. I want to show you we've got ordered pairs. Ordered pairs. None of this is in the textbook, but an ordered pair would be something like this. Coordinates on a graph is what they are. And I'm just making up random numbers. That's what ordered pairs would look like. We also have something called an arrow diagram. And this represents one set of information and the other set of information, and then arrows. So A is connected to D, B is connected to F, C is connected to E. This is called an arrow diagram. So we have a graphical representation, ordered pairs, table of values, and then an arrow diagram. And everything, no, I won't go there yet. Then we have what's called finite and infinite. Infinite. Finite, fixed number. So it doesn't go on and on, where this means it goes on and on. And on and on and on. We also will have what's called discrete. Which is going to be dots, points when graphed. And then we have continuous, which will be solid lines. So this means there are, we'll get into those definitions again later. So what it comes down to is relations connects two pieces of information. In this particular case, these dots represent the relation. Okay, this is that's how we connect whatever. There's no graph or no equation to go with this, but these dots represent whatever the relation is in this case. It could be anything. In this case, this area in here represents my relation. And then finally we've got this graph, which is called a parabola, which is created by quadratics, which we'll be getting into later. but the points on this graph are the relation. And again, all we're going to be doing for now is dealing with that quickly. And part of, I think I missed part, I think we are going to have what's called the domain and range. I'm going to double check these questions. Did I miss it? Nope. Here we go. So that was right. The other part of A, because the next page is B. Oh. Here's B. Talking way too much. These videos should be short. The domain of a relation is a set of all possible values that X may have. These are considered my independent variables. Independent values. Independent. And these are my dependent. Horizontal, vertical. Okay, the domain and range of a relation are often described using interval notation, which is kind of weird in this case because we're going to call that set notation as well. Considering the following examples. So we have this graph, and because our range, in this case, goes from this to this. So my range is a set of y values that go from, remember it's always set up, coordinates are always x, y. -2 is less than y, which is less than or equal to 3. All these silly little things we gotta get out of the way. Hollow dot, less than or greater than. Solid dot, less than or equal to, greater than or equal to. So that's where those symbols come in. And this is a hollow dot. So my domain goes horizontal this way. So my domain goes from, well, it's my x values, and they go from 1 to 5. 1 less than or equal to x is less than or equal to 5. Not less than or equal to, it's a hollow one. Less than 5. Hopefully I'm not rushing this. I know it's going to take some time, but you can ask questions on Monday as well. Now, so we had that. Now they don't bother to give us any information. In this case, just setting it up, if I put a line there, the graph occurs above it. So that means my domain, not my domain, my range has limitations. It can't go below -1. See, right there. All my y values are above that. So my range for y is greater than or equal to -1. These arrows means this graph goes on forever and ever and ever. So it keeps going up, but it also means there's no limit on x. So x doesn't have a limit. So x is contained in real numbers. So that symbol means part of the set. And R means real numbers. Okay? Now, a couple more quick examples. Here, I'm just going to use range. It's y. Y is less than or equal to 4. Domain, x. X is contained in real numbers. Now, moving on to the next one. I'm going to slide that over a bit. this one in black. So the solid dot means it stops here. That means it's going to continue on forever and ever. So what happens is my domain for x, so that's x is greater than or equal to -4. My range has a different limitation. Range. If I assume that it's going to be sinusoidal, which actually I can't, because it doesn't give us those values. This means this graph's going to take off and keep going up and up and up and up and up. So my range has a limit here. All my values are above that. So I'm going to get rid of that because that's not a limit. So that means y is greater than or equal to -6. So I got to pay attention to what the graph is showing me. Like I almost messed that one up, which is not unheard of. This case, we get something really interesting going on here. My limit my x's are everywhere but 0. So my domain x is less than 0, x is greater than 0. Or we can write it that way, or we can say x is contained in real numbers, but x does not equal 0. That's another way to write it. There's always going to be different ways, and people are going to see different things. Now my range is the exact same thing. It doesn't touch 0. So y is contained in real numbers. So any number can go in there, except at y cannot equal 0. Give me lots of questions on that to practice. Hopefully that makes sense. Don't forget to ask me more when we get to class. That's A.